Hello, everybody. My name is Blaxberg. I'm the CEO and founder of Wool Financial, and I'm so excited to be at CES together with the team from Nvidia. And today we have the pleasure of speaking with Dion, the Senior Director of AI Infrastructure at Nvidia. Thank you so much for joining the pod.
Thank you for having me. I love it.
An absolute pleasure. So much has been happening. So much has been revealed. And you're right at the center of everything. And data centers are really coming to the forefront. And I kind of want to start off with just a little bit of journey down memory lane of your career as AI, infrastructure continues to become a bigger and bigger part of what NVIDIA does. How has your role changed over the last several years?
Okay, thank you. That's a good question, and I'll kind of answer it and give you a slight correction. So I think when I first joined NVIDIA, I'll use that as a starting point. I've had many years in the data center. When I first joined, there was really sort of a transition that was starting to take place. One, people were understanding there was a shift happening from CPUs to GPUs. And so that's really the birth of accelerated computing, not just for gaming, but for general purpose computing. AI happened to be an incredible killer application, but it was also being proved out in other scientific domains, other different enterprise applications as well. And so as that shift happened, I would argue that we shifted from data centers to AI factories.
Yes.
And you've heard Jensen describe that, but it is a very nuanced approach to thinking about the infrastructure that serves these applications. Because in a data center, you're really thinking about how can I provide information that's already been calculated, already been sort of summarized in some database and provided to an end user. So your computing processing framework is much more north-south, just getting it out as fast as possible. When you're looking at an AI factory, so much of the work to generate tokens happens on the east-west, meaning the GPUs have to work in concert and communicate with each other. So it creates a different type of infrastructure requirement. And that's why when you walk the show floor, the Vera Rubin doesn't look like a single GPU. It doesn't look like a 4 or 2U, rack server. You see the full rack that's really being used to deliver those applications. So that transition has been, incredibly dynamic in the sense that, when I first joined NVIDIA back in 2017, most people understood AI was certainly now possible, but, after I will call it the ChatGPT moment in 2022, they understood, okay, there's a real technology here that can unlock intelligence for a number of different applications. So where we are today, there's an understanding not just about the models, but really about how do you leverage AI in every application. And that is what's driving the demand. Because, a lot of people don't fully understand why are so many people interested to go out and invest billions of dollars to stand up an AI factory. Absolutely. And the real reason is they want to basically be able to embed AI into every application. Think of every application that you interface with, that you use, that you engage with. That requires millions of users having access to tokens. And that demand is what's forcing us to have this annual cadence to really drive not just performance, but efficiency to help deliver these AI tokens.
What are some of your favorite AI applications?
So, I have a ton of them. Of course, there isn't a day goes by that I don't look at ChatGPT, that I don't look at Gemini, that I don't look at, Cursor, a number of other applications to really understand just the world. But then there's also more subtle applications where you see AI is affecting you on a day-to-day basis, whether you know it or not. Anytime you're being served an ad, anytime that you're looking for anything on the internet, a lot of the algorithms are now driven by AI to pair trillions of items with your specific interest in area of queries or just general understanding. So AI is definitely becoming more pervasive, and the applications I use are definitely transformed as a result of that. I'd also have to, say that I've become incredibly reliant on my self-driving car, and that's one of the forms of AI, that's physical AI that Jensen likes to talk about, that is definitely being materialized and demonstrating real capability. So AI is definitely pervasive, and it's interesting when I talk to my daughter, my cousins, people who aren't in technology. They understand the impact that it's driving, and they're already playing with tools. And so it's really exciting to see it really take hold.
Yeah, and it's continuing to progress, and it's only going to get more rapid, right, as we move down this pace. And something that I noticed that you've posted about and talked about online is balancing the efficiency with the sustainability as we continue to progress. Can you talk a little bit about that? Because Jensen actually made a good point earlier. Someone said, hey, using twice as much power, and he's like, well, we're 5 times as efficient, though, right? So you're actually cutting down.
Yeah, so if you, like I said, take a step back and look at the demand that's being driven. Like we talked about, as AI moves from model creation and usage to AI applications, that's creating an incredible amount of demand, right? And so a lot of that demand comes from usefulness of the models, having reasoning AI capabilities that can give you more reliable answers. And AI has gotten to a point where the usefulness is at a threshold. Now, if you take a step back and say, okay, how can you satisfy that demand? Most of our customers are going to be fairly power limited. So here's one area where business objectives and environmental sustainability objectives start to align, because the way that we're developing our platform is how do you get more performance per watt? Right. How do you get more performance out of that existing power envelope? But not only that, how can you drive down the cost of tokens so that you can go service those millions of users through all of those applications?
Something like Nemotron, right?
Exactly. So it's really about understanding how do you balance the usability and the performance, but also how do you deliver that as efficiently as possible. And in doing so, we actually reduce the overall amount of power and energy per token significantly. In fact, we've demonstrated that over the last 10 years, we've decreased the energy per token by about 100,000x. Rubin will add another 10x on that, so it'll be a million x by the time we're rolling out these Rubin platforms. The other thing that has a very unique and direct contribution is when you look at the water impact.
Yeah.
It's kind of counterintuitive, but the fact that Vera Rubin is 100% liquid cooled, it will actually save water, because you're not using air-conditioned chillers that evaporate water. You can basically have a closed-loop system that can actually be 300 times more water efficient.
And he said 45 degrees Celsius on the water?
So the fact that you're able to run it at 45 degrees Celsius, that reduces the requirement to leverage a lot of those air chillers, which again helps save on not just energy, but also water.
Right, which seems to be like, that's why they're talking about, hey, we're going to put data centers on the moon, right, and all these different things.
That's right.
We need to have the ability to cool that heat that's coming off. But when you have advanced breakthroughs like this, it kind of almost negates some of that.
Exactly. So, I mean, and the thing is, we're going to need all of it, quite frankly. I mean, when you look at the demand and how we're trying to help, facilitate this build out, you're going to need all the different innovations, and that's how we approach it. Like, where are all the areas that we can leverage new technologies, new approaches, put data centers in new places to help deliver the performance and efficiency that's required to kind of keep pace with that demand.
What's the most, not wild or crazy, but in that direction place that you realistically think we could see data centers popping up in over the next several years?
Well, I mean, we've recently had some announcements with Star Cloud that we have actual GPUs that are being ran, GPUs that are being ran to run work. I'm sorry.
No, I know. We got to get some water.
Yeah. So we recently announced a project with Star Cloud where they're deploying AI infrastructure in space for some of the reasons you talked about, being able to tap into the solar power and not having to worry about day or night. Also, the cooling becomes less of an issue, so we see that that's a real possibility. But also, when you look at where AI factories are being deployed today, they don't need to be built and used near highly populated areas, especially if you're using them for training. So having them areas where there's plenty of cheap, clean energy is certainly a thing that you're seeing a lot more of when you're seeing how these AI factories are being built out.
Yeah. Do you ever see the memes of them showing, like Central Park and it's just all one giant data center? They're just like, I have an idea.
Yeah. Well, I mean, again, I think it really is about, it's kind of funny, but I think the idea is that people understand the importance of what's happening in this shift in terms of this AI factory transition, and it will touch so many different aspects of our lives. And there's going to be a strong requirement for more compute, but that might be too far-fetched.
Maybe a little too far. Don't take Central Park.
That's right.
Pulling back for a second to kind of the AI factories and more of this high-level stuff.
Yeah.
For a long time, when people look at it, they say NVIDIA's a chip company, right? Like at its core. And I do kind of want to ask you if you think that's changed a little bit. But in addition with that, you've moved from kind of segmented areas to where hardware, software, networking, everything is kind of together, right? It's all now in line. And that seems to be the big breakthrough. Yeah.
So I think what's really interesting, NVIDIA is certainly still a chip company. In fact, when we talk about Vera Rubin, it's actually 6 different chips.
Right.
There's a Vera CPU, there's a Rubin GPU, and within that compute tray, we also have a Connect X9 SuperNIC, which connects the compute to all the different racks across the data center. You also have a Bluefield 4 DPU, which offloads a lot of the data processing and security isolation to allow those CPUs and GPUs to focus on performance. But then all of those systems are connected via our NVLink switch tray, which has another chip that is about scaling up the infrastructure and allow them all to talk to each other at 3.6 terabytes per second, all-to-all line rate, which delivers that 260 terabytes per second for the in total rack. So it's about figuring out how can we implement what's called this idea of extreme co-design. How can we make sure that all these chips are designed in such a way that 1 + 1 = 3, instead of just really focusing on the chip itself. And then on top of that, we have our Spectrum X CPO switch, which is our co-packaged optics photonics-based switch that allows you to connect hundreds, millions of endpoints potentially in a much more efficient and performant way. So all of those chips work in concert. But we actually make it even harder on ourselves.
Of course.
We want to make it completely vertically integrated to deliver what we call speed of light. But we also make it completely disintegrated so that if AWS wants to deploy using their EFA network, they can do that. Or if they want to use their Nitro DPU, we can make sure that that works as well. And so the fact that we want to build this fully integrated, 6-chip based stack is really how we unlock that, what we call state-of-the-art performance. But we also recognize that every business is going to be optimizing their own business calculus. They may have existing technologies or other systems they're using in their data center by which they want to leverage that. And then we make that even more complex. We have something called NVLink Fusion, where we will allow other processor families to run within our scale-up architecture. So we're certainly pushing the bounds on, adding more work to our plate, but we want to make sure that we can service everyone in the industry to provide whatever it is that they want to buy from us, whether it's the full stack solution or whether it's some of the specific elements to help, deliver their objective.
Yeah, the more you're talking, the more questions are coming to my mind, so I'm going to try to condense them down.
Sure.
But I think that also one thing that you mentioned there at the end is really why having open versus closed source is also so important, right? So that people can take pieces, build on top of them. And the idea here is we can basically anyone can use our technology in any way, shape, or form. It can be their full stack and can be a part of it. They can build off of it, and that allows you to integrate worldwide.
And that's something that I don't think has ever been done before in this industry. To have the level of vertical integration that we've gone to with developing something like the NVL72, but also work in every cloud, work with every OEM, with every sort of ecosystem partner that exists out there. In fact, we have the saying we're the only AI company that works with every AI company.
Yeah.
But to do that is very difficult. And I think when you also couple that with the idea that we're not just doing it once, we're doing it every year, and we're leapfrogging ourselves to keep up with that demand, but also to deliver more efficiency to help power a lot of those AI applications.
So one thing which is a product of that is that you're consistently creating new chips, right? New technology, and so now moving to the GB 200s from the H100s.
So we've moved from H, which is Hopper, to GB 200, GB 300.
Correct.
At the show, we've announced Vera Rubin, which is another sort of step function in terms of performance. And I think just one thing to hit on there, as we moved from Hopper to Blackwell, that introduced a whole new computing paradigm and infrastructure requirement for the data center. Instead of just shipping air-cooled racks, air-cooled systems, now we have this full vertically integrated scale-up rack-to-scale system. That required new bus bars, that required new liquid cooling apparatus, that required all these different elements to redefine, reshape how the infrastructure build out was going to take place. So what was very important to us is we moved from Hopper to Blackwell. We saw that was a huge shift, and every ecosystem partner was on board with us to do that. As we moved from Blackwell to Vera Rubin, we were very conscious about trying to remove or eliminate as much friction as possible. So it's the same rack scale dimensions. It can take that same MGX NVL72 rack and deploy Vera Rubin. It's the same liquid cooling apparatus. It's the same sort of general approach. And so as people migrate from Blackwell to Vera Rubin, you're going to see even faster adoption. So it's pretty cool.
So one question I do get a lot of times from retail investors is, okay, what's happening to, the Hoppers? What's happening to the Blackwells? As you keep moving forward, what is the best way to utilize this technology that now is not up to par?
Yeah. So here's the thing. There's two things that kind of are at play here. If you look at the spot pricing for a Hopper in the cloud, right now they're fully subscribed.
Okay.
And in fact, the price per Hopper is actually going up. That's in spite of Blackwell coming to market in mass. And the reason why that is, there's two reasons. One is because we continue to improve the performance and efficiency of the platform over time.
Okay.
So the Hopper that we deployed, 4 or 5 years ago is not the same Hopper that's used today, because through software enhancements, through a number of innovations, we've actually improved the performance of Hopper by 5 times in a single year, right? So that's with the same hardware, they're getting 5x more performance out of that system. But then when you also couple that with the fact that the demand, as we go back, as I described, the demand is still outpacing the supply for for the computing industry. So one of the reasons why we're on this annual cadence is to try to go and address that demand, because of course you could do it with more hoppers, but you want to try to do that as efficiently as possible, and that's why we're on this annual cadence, so that we continue to add value. Now, the interesting thing about it is because you can still get more value out of a hopper, and Blackwell will be the same. Again, the software improvements, the overall model attributes that they will basically add more value to get more performance.
Right.
That's essentially going to help those who are deploying Hopper, those who are deploying Blackwell, to still get value. And so there's still a tremendous amount of value even leveraging those systems. And so that's really where our focus has been, is not just to land it and forget it, but basically to make sure we can continue to innovate, continue to deliver software improvements, continue to work with model builders to help them adopt, for example, the new Nvidia FP4 Precision. That's instant performance that they can get out of running that model on Blackwell, even though Rubin will come later, right?
No, I love it. I think a lot of people maybe aren't paying attention to those software updates that are coming through, right, and continuously improving. And a 5x improvement in 1 year, like you said, is incredible. I could go pretty far on the technical side, but I do want to ask a few things on the other areas. So what attracted you over to Nvidia?
Well, you know what was interesting is I would love to say that I had this great foresight about where AI was going, and this was really the drawing factor. But for me, it was really the people. I mean, obviously, whenever you're considering a place to work, you're trying to understand, are you going to enjoy the people you're working with? I had the opportunity to meet with a number of folks. For example, I'll shout them out, Dr. Ian Buck, who's my boss now. I remember meeting, interviewing with him, talking with him, understanding what the mission is for NVIDIA. Yeah. And afterwards, I think I went and looked him up and just saw how important and impactful his career was on the overall technology landscape. And everyone I met had that same sort of humbleness, much more focused about the mission than their own personal sort of gratification. And so I think that culture was very pervasive in making me want to join. And as I joined, like I said, back in 2017, AI wasn't really the sort of movement that it is today. A lot of people didn't fully believe in where AI could go, but being a part of that ride, helping to steer that transition and that transformation is what makes it exciting.
Okay, so follow-up question. Besides for Dr. Ian and Jensen, who is the most influential or impactful person in your life that you've worked together with at NVIDIA, and why?
Wow, there are so many impactful people. I think I'll just describe the culture, and this will kind of answer your question but not answer it. NVIDIA has a couple of concepts, and I think a lot of it has been talked about publicly already, which is no one fails alone, which means it's not any one individual who's trying to tackle a problem. You're only held accountable if you don't seek out the help of others to really tackle it as a team. So that is certainly true. The other sort of NVIDIA-ism is the mission is the boss. And what that means is the notion of hierarchy doesn't really come into play as often. Like, in other words, if someone's considered the pick or pilot in charge for something that's important to the company, they have the entire company at their disposal. And so that culture breeds a mentality that isn't about a hero mentality, that it's just one person, because you recognize any work that I do builds on the work that engineers did, or builds on the work that our finance people did. And so all of those sort of cultural shifts just really create an environment where on any given day, I have 20 people that I could absolutely thank and call out as being instrumental for helping us do the job that we need to do.
Yeah, very fair. And then I asked a version of this question to Jensen earlier today, but he did not give me a direct answer, so I'm going to throw it at you, and I'm going to rephrase it a little bit. To the long-term investors, that are watching in my audience, what would you tell them? Like, hey, right now, this is something that's not possible, but with the advancement of data centers, AI factories, here's something that 5-10 years in the future that might be possible, or I believe will be possible.
Yeah. Well, I'll go out on a ledge a little bit. And a lot of my early time at NVIDIA was spent focusing on the scientific computing domain. So the advancements we're seeing in scientific computing leveraging AI kind of go under the radar. And so there's a couple of key areas that I'm really excited about. One is in the renewable space. You're seeing a ton of work helping to drive the advancement of fusion reactors and fusion energy. So for example, there's AI surrogates that are being developed to help model the physics of a tokamak, which is really an instrument that can generate or harness the power of the sun. And so seeing how quickly those advancements are actually taking shape I think it's going to accelerate the pace of those innovations that years ago we would have said we wouldn't even think about that in the next 20 to 30 years. But now that we see a lot of these new AI techniques being used and leveraged to accelerate that research, I would argue that in the next 5 to 10 years, you'll see a real working example of some of those fusion reactor type experiments really coming to life.
Okay, that's pretty awesome. I will say that is
right.
something that people should be looking forward to.
Yeah.
This was incredible. We deeply appreciate your work and everything that you do on the company. And obviously, many of us are shareholders and big fans of everything that you're doing. Any final message that you would want to share with the average everyday retail investor who just owns some Nvidia and is a fan of the mission?
Yeah. Well, I would say, much like I talked about earlier about the cultural shift, the mission is the boss. I mean, I think when Nvidia approaches how we go to market, it's not with a financial objective in mind. In fact, there's this saying, play the game, not the score. In other words, if we do the things that we can control, do the things that we are responsible for, and take our position as a steward in the industry, seriously, but understand that that Nvidia has that approach first and foremost. So as long as we protect that as a cultural sort of guidepost, I think we'll continue to do well, right?
I like that. Play the game, not the score.
That's right.
Wise words. Thank you so much for taking the time.
Thank you so much. Thanks for having me.
Appreciate you.